The other day, whilst operating my lathe, I noticed the motor suddenly started misbehaving. It juddered to a halt, and I noticed that smoke was coming out of the top. I immediately switched it off. I disassembled the motor from the housing at the back of the lathe and moved it onto my workbench so I could give it a closer look, see if I could find out what the problem was. The motor is a 240 volt AC split phase centrifugal starting induction motor. It runs at 1425 RPM and is 1/3 of a horsepower, which is approximately 250 watts. It was suggested to me that maybe now's the time to get myself a 3-phase variable speed motor. I looked into the cost of one of these, but with the inverter needed it was rather expensive, so I thought I'd have a go at overhauling my old motor. The motor itself was made by a company called Metropolitan-Vickers, also known as Metrovic. I went online and looked up the history of Metropolitan-Vickers. The company was established in 1899 by George Westinghouse and was an Anglo-American venture. They were a heavy engineering company and they built generators, steam turbines, transformers, switchgears, and also in the 1920s they also built electric locomotives. And of course they built motors. During the Second World War, the company secured an aircraft assembly contract and in 1938 began to build the Manchester bombers based at the Trafford Park site. And then later they began assembly of the 4-engine successor of the Manchester, the famous Lancaster bomber. I realised that this motor company really did have quite a provenance, so I decided that rather than upgrade to a 3-phase system, I would actually try and refurbish this nice old motor. It seemed like it wasn't quite yet ready to be destined for the scrap heap. So I started to disassemble the motor on the bench. I removed the collars which held the vibration dampening rings, and this allowed me to remove the mounting foot from the motor. Now this is an open framed motor, which means it has holes in the end bells which allows air through the motor to allow for cooling. Now this motor's probably been on my lathe for as old as the lathe is, and that's 71 years old, so I'm guessing this motor probably hasn't been opened for at least that amount of time. And as you can imagine, lots of bits of swarf and dust and grime have managed to get in through these holes and is probably the main cause of the failing of the motor. I removed the 4 retaining bolts which hold the end bells onto the motor. A few taps on a copper-ended drift allowed the end bell of the motor to become detached, and I gently slid off this end. The first thing I noticed was that the cables themselves seemed to be in quite poor condition. It felt like there were some weak spots in the cables where they bent rather easily, and there was also evidence of a green sludge, a sort of corrosion, had been leaching through the braided heat-resistant cable sleeving, so I guess these were going to need to be replaced. With the end bell now detached, I could easily slide the rotor from out of the motor. The stator looked quite dirty, and there was a lot of grime and swarf and bits of dust inside, and I could also see further wire corrosion. It didn't smell like it had been burnt up in any places. The centrifugal switch arrangement appeared to be in good condition. Although dusty and a little bit rusty, everything seemed to move quite well. And the same goes for the electrical switching mechanism itself, although it was quite dirty and certainly needed a good clean. The motor doesn't have bearings, instead it just has a sleeve bearing, which is possibly made from either white metal or bronze. The bearings looked in very good condition, and they were nicely made with oil grooves that ran down the inside, and an oil reservoir feeder on the outside. These looked in pretty good condition. The electrical contacts, on the other hand, on the switch, looked as though there'd been considerable arcing during switching, and this would obviously need some work. Now, whilst cleaning, I didn't want to get any dirt or grime into the sleeve bearing. I measured up the motor spindle, which was 0.625 thousandths of an inch, which is 5/8 of an inch. I then found a piece of silver steel ground bar, which was also 5/8 of an inch, and this fitted nicely down into the sleeve bearing. I left this in place whilst I cleaned out the end bell to prevent any dirt getting inside the bearings. As you can see here, the mechanism still functions quite well, but it was very dirty. I snipped off the 2 wires which connected the switch to the starter windings, and then removed the screws to be able to get to the switch itself. It was evident that a lot of arcing had been taking place, and when looking at the contacts, they appeared to be slightly misaligned, and the contact was only being made on one very edge of the actual contactor. I did some readings of the main running windings and also the starting windings. All this seemed good. I also then used some paraffin to clean the switching unit and also the bell housing. I attempted to remove the spindle pulley from the end of the shaft, but this was solid, so I decided in the end it wouldn't actually impede me doing my repairs on the motor, so I just cleaned it in situ. The centrifugal switch seemed in good condition, although it was a little bit rusty. This time I used a bit of WD-40 and worked it in between all the moving parts on the switch. I then gave it a good old blast with compressed air to blow out any remaining dust. I also did exactly the same with the stator. This was actually quite dirty, and there was a lot of swarf around the back of the windings. You can also see here a lot of the green oxidisation which has leached through the cable braiding. There was also a small area which was showing copper, so this was going to need to be replaced. It did, however, clean up quite well, and most of the copper of the windings looked fairly bright and clean. To clean the actual contacts of the switch, I took some self-adhesive 800 grit aluminium oxide paper and slid it between the contacts. I also noticed that the contacts weren't sitting absolutely square, so I used a pair of pliers just to gently bend the contact until the 2 electrical contacts came together nice and squarely. As you can see here, they now mate much better than before. I also cleaned up the 2 pads which make contact with the Bakelite pressure ring on the centrifugal switch. As I only run my motor in one direction, I decided to make 2 copper terminal connection strips rather than having it interconnected by separate wires. The hole markings were centre punched and then drilled through. A quick fit check was made and then the rest of the holes were drilled. I took the copper sheet to the bandsaw and gently cut out the terminal connection strips. These were then cleaned up with a file and test fit was again made. Some slight adjustment had to be made to the second connector as the hole spacing wasn't exactly perfect, but a round file took care of this problem. The 2 terminal connection strips would then be clamped in situ when the wires were added later. The base of the motor had shown signs of rust, so I cleaned this off with a wire brush and some sandpaper, and then I gave it a coat of red oxide paint. When this was dry, I then overcoated it with some black spray enamel paint. The problematic supply wires, the ones that were showing the green oxidisation, were gently prised from the motor and cut back until fresh copper was found. New wires were then soldered on, and a length of heat shrink tube was slid over the soldered connection. I then obtained some braided heat resistant cable sleeving, and this was then also placed over the heat shrink. And finally, some larger heat shrink was then placed over the top of the two braided cables where they met, and this was shrunk down to secure the braiding on the cable. I did this with both of the conductors which supply the main running windings. The cables supplying the starter winding didn't seem too bad. The wires were then gently bent into shape around the side of the stator and then secured with small cable ties. The ends of the conductors were shaped to form a ring to suit the terminals. These were then soldered together, and again heat shrink was added to the end of the braided sleeve to neaten up the job. The motor was now reassembled, ready for testing. A new rubber grommet was found and fitted to the motor with the supply cable. The motor was connected back up with the earth lead connected to the body of the motor, and then a fly lead which will also connect to the housing on the lathe to ensure that it is correctly earthed. Here now you can see the terminals connected with the copper bridges in place. A 13 amp 3-pin plug was temporarily fitted to the end of the supply cable so I could test it on the bench. The motor has two little wick oilers either side on the bearing housings. These were then refilled with oil. You can see it opening and closing. Closes. You can see the centrifugal switch operating here as the motor is turned on and off. Opens and closes again. And as you can see now, the motor is running nicely with very little vibration. I'll just bounce the queen on there. As you can see, very little vibration. So another great good old British motor rebuilt. And finally I mounted it back on the lathe and we're all back in business again. So I can now go back to doing what I enjoy most, using the lathe.